Welcome to Geometry Pre-AP. This is the last day of proofs. This is proof days 3. Today we're going to learn about proving corresponding parts of congruent triangles congruent. And that's a pretty big mouthful of words, but it is a saying. And so that saying is CPCTC. And so you need to write this down. And so this is the abbreviation we use. And we use CPCTC. CPCTC. Which is this: corresponding parts of congruent triangles are congruent. One of the key factors here is that you must prove the triangles congruent before you can use this. If you ever use CPCTC before you've proven the triangles congruent, the proof's going to be completely wrong, so don't do that. All right, so here's our first proof. So if you want to pause the video and see if you can just prove the triangles congruent, that'd be great, and then it can finish up the proof for you. Okay, so we got this information is congruent to this. We've got this congruent to this. We know we can bring the reflexive property in now, and we know these two triangles are congruent by angle, side, angle. But notice what our proof says. Our proof says we need to prove that this piece is congruent to this piece. Well, if the triangles are congruent, then that means any other parts of the triangle that we haven't used yet also have to be congruent. And that's where the CPCTC comes in. So we have this information to start. So we go here, here, and here. Remember, this is reflexive property. These are given. And then from those, we come all to here, where we say our two triangles are congruent. And this is by angle, side, angle. And finally, if the triangles are congruent, then any of the other corresponding parts are congruent. So we come to here, and we say CPCTC. So this allows us to prove any other parts of triangles are congruent. And we're going to use these proofs all throughout the next few chapters of geometry, learning how to do other theorems and things like that. Okay, so here's another one to pause. And if you want to, pause the video, prove the triangles congruent, and then after that, I'll finish the proof up for you. Okay, so we have C as the midpoint, and by now you should be getting pretty familiar with those steps. And then a midpoint creates two congruent pieces. So this was given. This is definition of a midpoint. Sorry, my handwriting's a little rough. Okay. And we have our reflexive property. In case you didn't put that information here earlier, this is what we have. Now, we go in here. We have AC is perpendicular to BD. We know it creates right angles. But then the question is after those right angles, where are we going with this? Are we going to say right triangles? Or are we going to say right angles congruent? And let's look here. It's not going to be an HL proof, so we're going to say that those right angles are congruent. And so here we have this last piece. So this was given. This is definition of perpendicular lines. This is definition. Actually, it's not definition. This is right angles are congruent. And then all of this comes together. In case you forgot, this was reflexive property. Okay. And then our triangles are congruent. Sorry, my nose is running a little bit tonight. All right, and so these triangles are congruent by side, angle, side. Now, that was the first part. You should have been able to do all this on your own. Now, the next part says we want to prove that AC bisects angle BAD. So if AC bisects angle BAD, that means these two angles right there would have to be congruent in order for AC to be a bisector. And since those are parts of the triangle, then I can say those two angles are congruent. And since they were parts of the congruent triangles, that's the CPCTC part. And that if I can say those two angles are congruent, then I can say that AC is a bisector by the definition of an angle bisector. or the definition of angle bisector is if something's angle bisector creates two congruent angles, and the converse is also true. If I have two congruent angles, then I have the angle bisector. And there's our proof. All right, here's another one. I want you to prove this triangle's congruent first, and then I'll finish up the proof. All right, so we got W, Y, and XZ bisect each other. So that means we're going to have a congruent piece here, a congruent piece here. All right, and so then we're going to use some vertical angles in here. And when I do that, then I have my triangles are congruent by side, angle, side. So I know what I'm going to do for my triangle proof, and so that's what all of this down here is doing for me. So I'm just going to uncover it, and then I'll fill in all the reasons here for everybody. All right, you should be able to do this with no problem on your own by now, because these are just like the proofs we've been doing so far. Usually on the test or on the final exam, I almost always have one of each of these proofs, and one of the proofs is always a CPCTC proof. So you got to be able to use CPCTC. This gives us two different things here. And then we go to our congruent triangles here, 2, 3. This was given. This was given. This is both a definition of a segment bisector. I'm going to change colors. Definition of a segment bisector. Definition of a midpoint. Definition of a midpoint. Actually, this wasn't given. This is definition of vertical angles. And this is vertical angles are congruent. And then this was side angle side. All right, so we have everything written in here that prove the triangle's congruent. You should have been able to do this with no problem. All right, and so once I have a triangle congruent, I'm trying to prove that WX and ZY are parallel. In order to prove lines parallel, remember you had to prove a special angle pair congruent. And so I'm going to go with here just angle Z and angle X. So angle Z and angle X are congruent. And those are corresponding parts of the two congruent triangles. So CPCTC. And once I prove those angles congruent, then I can say the two lines are parallel. I've seen some people doing their proofs already saying parallel lines make congruent segments, and that's not true. Don't do that. Okay, so there was our CPCTC here. And if the alternate interior angle is congruent, then by the converse of the alternate interior angles, then the two lines are parallel. And that's our proof. So again, make sure you're going through the process. Don't use CPCTC until you've proven the triangle's congruent first. This is our last proof. If you want to take a minute, pause the video, run through this whole proof, see if you can do it. That'd be great. At least prove the triangle's congruent, and then start the video again. All right, so if we look at this video, YZ is parallel to MN. We got YZ that's congruent to NM. Remember, if I have a parallel line, I've got some congruent angles, so that means angle 3 and angle 2 are going to be congruent, and angle 1 and angle 4 are going to be congruent. And so it looks like my triangles are congruent by angle, side angle. So I'm going to take care of that part. Here is that part of the proof. So you shouldn't have too much issue doing this. You've done a few proofs by now with this. And so I'm going to use a different color to write my reasons. So this was given. This was given. This is alternate interior angles theorem. This is alternate interior angles theorem, and this was angle side angle. Now, by now you've probably done some proofs with segment bisectors. And so when you have a segment bisector, you gotta say there's a midpoint. Once you say there's a midpoint, then you can say there's two congruent pieces. So if we're gonna prove a bisector, we're gonna reverse that process. So I need two congruent parts first. That's what I need. So if I'm trying to prove yn bisects mz, so this is the segment I'm trying to bisect, I need to know that's a midpoint. And so I need these two pieces congruent to each other. And so that's where I'm going to start. I'm going to say those two pieces are congruent to each other. That's my CPCTC part. Now, if I have two segments that are congruent to each other like that, and they both share that value, that letter x, then I can say x is the midpoint. And that's by the definition of a midpoint. Remember that definition of midpoint goes both directions, forwards and backwards. So two congruent segments, a midpoint, two congruent segments. And finally, I have one last piece here. If I've got a midpoint, now I can say I've got a segment bisector, which is right there. And so there's my segment bisector. And my reason is definition of a segment bisector. So these proofs aren't any different than the other triangle proofs. There's just something to do after you prove the triangle is congruent, where you use the CPCTC to use a piece of another triangle, of the triangles that you're using, to prove something else congruent. All right, and that's the end.